Today we are going to learn the equations reducible to the homogeneous form. We have already covered in the last video the variable separable method of solving the differential equation. So let's begin. So in the homogeneous form, the general form of the differential equation is this. And the power of the x and the power of y are equal. Otherwise we cannot make a solution out of them. And if a by a is not equal to b by b, then we can proceed with the homogeneous method. So this is the first condition we have to follow to make a solution of the homogeneous method. So if this happens, that small a by capital A is not equal to small b by capital B, we will substitute x equal to x plus h and y equal to y plus k. Small x equal to capital X plus h and small y equal to capital Y plus k, where h and k are constants, but the capital Y and capital X are the variables as small x and small y. Then dy by dx can be written as d of y plus k divided by d of x plus h. So as the constant terms vanishes in the differentiation process, so it becomes dy by dx. So dy by dx is equals d capital Y by d capital X. Now take an example. Say dy by dx is equal to x plus 2y minus 3 divided by 2x plus y plus 5. So so here we can see that the coefficient of x is 1 and here is 2. The coefficient of y is 2 and here is 1. So 1 by 2 is not equal to 2 by 1. Hence we can proceed with the homogeneous method. So what will we do? We will substitute small x equal to capital X plus h and small y equal to capital Y plus k. So dy by dx becomes x plus h plus 2 into y plus k, 2 into x plus h plus y plus k plus 5. Oh, yeah, minus 3. Okay. Then let's open the brackets. Okay, we got this. Let's do one thing. X is a variable, y is a variable. So why not we separate them with the constants, from the constants like h, 2k and 3. Okay, let's do that. It becomes x plus 2y plus h plus 2k minus 3 divided by 2x plus y plus 2h plus k plus 5. So the constant terms are separated, the variable terms are separated. Now let's find the values of h and k. So we will write this. Okay, so we can solve these equations by any method, you know those. So I'm gonna go with multiply 2 with equation 1 and 1 with equation 2. So 2h plus 4k minus 6 equal to 0. 2h plus k plus 5 equal to 0. So subtract this, it becomes 0 plus 3k minus 11 equal to 0. K becomes 11 by 3. If k becomes 11 by 3, h plus 2k minus 3 equals 0. So h plus 2 into 11 by 3 minus 3 equals 0. So up to the solution, we will get the h value minus 19 by 3. So the differential equation reduces to dy by dx equals x plus 2y divided by 2x plus y. Okay, now put another substitution, y equals to vx. So dy by dx is equal to v plus x dv by dx. This is the chain rule of differentiation. So dy by dx can be substituted as this. So v plus x dv by dx is equal to x plus vx divided by 2vx, 2x plus vx. Now, why we have done this substitution? The substitution is made to convert the differential equation into variable separable form to make the solution easy. So this can be written as, taking x as common, 1 plus 2v, 2 plus v so this v can be subtracted from this. So this cancels out. So this is the remainder. So now what will we do? We can do that x by dx equals, the dv can be divided into this. Now reciprocate. we will get this. So we can also write this equation as 2 dv by 1 minus v square plus v dv by 1 minus v square, right? So integrate both sides. We will get it becomes ln x, and we know that constants cannot be integrated if there are variables, so it becomes dv by 1 minus v square plus v by 1 minus v square into dv. So the solution becomes, this is 2 into tan inverse v, as the derivative of tan inverse v is 1 by 1 minus v square, and the integration of v and 1 minus v square dv. So how do we solve this? Consider a multiplication of 2 in the numerator and the denominator, 2v divided by 2 into 1 minus v square dv. So take this 2 outside of the integration, so 2v divided by 1 minus v square dv. Take a minus here and here, so okay. So now we can see that the derivative of the denominator term is the numerator term, 1 minus v square. Its derivative becomes minus 2v. So we can write that the integration of the whole term can be minus 1 by 2 ln 1 minus v square. So put this value on the in the equation, ln x plus 2 tan inverse v minus 1 by 2 ln 1 minus v square equals plus c. So ln x plus 1 by 2 ln 1 minus v square is equal to tan inverse v. Now let's put the values of x, v. Ln the small x was equal to capital X plus h, so the capital X will be small x minus h, plus 1 by 2 ln the v was the y, the capital Y, the y equal to vx, so v will be y by capital X 1 minus capital Y square divided by x square equal to 2 tan inverse y by x. Now y can be substituted as small y minus k, and x can be substituted as small x minus h. So this is the final solution of the differential equation in the homogeneous method. It is a bit long, but it's very easy. We can take another example for your better understanding. The question is, solve x plus 2y into dx minus dy equal to dx plus dy. So how to make the solution, right? Let's do this. Multiply x into dx minus dy plus 2y into dx minus dy is equal to dx plus dy. Okay, let's separate the dx terms and the dy terms. Take the dx in common and dy common. So now dy by dx becomes okay. So here we see that 1 by 1 is equal to 2 by 2. The coefficient of x's and the coefficient of y's, the division, that becomes equals. Then it is a case of failure. Then what will we do? The a by a becomes equal to b by b, right? We can see that the x plus 2y is common here, right? So put x plus 2y equal to z. So if we put x plus 2y equal to z, then dz by dx becomes 1 plus 2 dy by dx. Oh sorry, these are small. So we can write that dz by dx minus 1 equal to 2 dy by dx, right? So dy by dx can be written as dz by dx minus 1 by 2. So dy by dx becomes 1 by 2 dz by dx minus 1 by 2. Okay. So now put this dy by dx in this equation. So 1 by 2 dz by dx minus 1 by 2 becomes z minus 1 divided by z plus 1. So x plus 2y becomes the z, right? So dz by dx becomes z minus 1 divided by z plus 1. This is added with 2 multiplied in the whole term. So now dz by dx equal to 2z minus 2 divided by z plus 1 plus 1, right? This 2 is multiplied with both the terms. So dz by dx equals 2z minus 2 plus z plus 1 divided by z plus 1. So 3z minus 1 divided by z plus 1. Right, so just variable separable method. Dz is multiplied by here. If we reciprocate them, dx is equal to z divided by 3z minus 1 plus dz by 3z minus 1. Right, now we have to integrate both sides. Okay, we can solve this. How we will solve this? So this becomes let's multiply 3 on the numerator and the denominator. Now let's add 1 and subtract 1. So 3z minus 1 divided by 3z minus 1 dz, and okay, so we can do this and ln 3z minus 1. Right, so the equation becomes x equal to 1 by 3z plus 1 by 3 ln 3z minus 1. This becomes ln 3z minus 1 plus ln 3z minus 1. So small x equal to z by 3 plus 1 by 3 ln 3z minus 1 plus ln 3z minus 1. Now we can substitute the value x plus 2y equal to z. So this is the final solution. Okay, practice more of these questions. Let's give you some questions here. So these are your homo questions you will solve to practice more about the homogeneous methods. That's it.